Alright, I have no idea how this is going to go, but we'll see. So, this is kind of a hands-on version of the lab that's going to be done, or the simulations in the physics classroom. I'm going to try to figure out a way to do this better, but we'll see. So you can see here, this is a normal D cell battery. Hey, it's not even expired yet. December 2023. These are small bulbs. So these are versions of the type of bulbs you might screw into like a lamp or something like that. The thing that's characteristic of these is they've got metal on the side, metal on the bottom, and then bakelite, which is a type of plastic in between. So this is a conductor and this is a conductor. In order for bulbs to work, you need to actually have this touching a piece of metal and this touching a piece of metal. So the electricity goes through one side and then to the other. So essentially you've got to have a complete pathway. You could think of one of these being positive and the other is negative if we're talking about a DC circuit. Which one it is which doesn't matter, it's just that they've got to touch different parts of the circuit. So in order for this to work with one wire and one bulb, it doesn't particularly matter. I can set this down here so the bottom of the wire is touching the negative. And if I touch this up here, obviously it's not going to work. But here, if I touch it like this and then this onto the side, it does work. If I touch this here and this onto the side, hold on, yeah, it works as well. Not particularly bright. This is a different type of bulb. It's got a different filament in it with a different amount of resistance. There's no way you'll be able to see that. But one of the ways you can tell it's different is if we do this, touch this on the bottom and this on the side, it lights, but it's much, much dimmer for the same amount of battery voltage. So that's a simple version of the experiment, one of the concept builders. I want to show you some of the other equipment that we would be using. We'd normally use a power source like this, which is variable. It goes from 3 volts all the way up to 12 volts and 1.5 volt increments. We have an output that's positive, input, or another output that's negative. So current we think of as flowing from positive to negative. Oftentimes we measure current with this, which is an ammeter. So there's 3 scales here, a 5 amp scale, a 500 milliamp scale, and a 50 milliamp scale. You would always want to hook up to the highest scale first so that you don't overload the ammeter. These can blow up or blow out really quickly if they're overloaded with current. A voltmeter, and you hook these up in series with whatever current you're trying to measure. A voltmeter is hooked up in parallel because you're trying to find a voltage or potential difference around an object like a resistor or bulb. So this has a 15 volt scale and a 5 volt scale. Again, you'd start on the highest one unless you knew for sure, say this was set on a 3 or 4.5 volt setting, then there'd be no reason to use the 15 volt scale. So in this particular case, this is another thing which we would use often. It's a multimeter. It can measure DC voltage. That's the symbol for direct current. This is the symbol for alternating current. We don't use that in our labs. Resistance down here in ohms. Current, these are microamps and milliamps, and this is a 10 amp scale. That's normally the one we would use. We'd normally use a 20 volt scale here. So one of the wires would always stay in here, something called the common ground. And then if you're measuring voltage, resistance, or milliamps, you'd put the other plug in here. If you're measuring current in the 10 amp scale, you'd put the second plug in there. So we always keep that one in, and then we can alter the other ones. Multimeters can be a little bit different, but they have similar functions. So each group would end up getting a bag of resistors and wires, and we may end up getting some like Christmas tree bulbs, things like that. So this is a 50 ohm resistor. This would be a 10 ohm resistor. They all look the same on the outside. And if we want to really see if they're correct in what they're doing, we can measure that. So this one says that it's 47 ohms. So I'm going to take a look at that. I'm going to turn this on. I'm going to put it on the 200 ohm scale. Oh, that just means that it needs a new battery at some point. That's not great. So when I touch these wires together, says that it's about 1.7 ohms, 1.6 ohms of internal resistance. That means whatever I read through here, I would need to subtract 1.6 ohms off of. So when I put this together, it says 47.2 is going down. That's interesting. So I'm going to say that's 2 ohms of internal resistance, and this is about 46.0 ohms. I'm wondering if that's due to the fact that this battery's going bad, that it's changing that reading. But anyhow, whatever reading I get, let's say it's 47 ohms, I'd subtract off the 2.0 ohms of internal resistance. Usually it's less than that, so I'm betting I got a bum one. And then we have a bunch of wires here. The colors of them don't matter. That's just to help you keep them straight. We normally use those to hook up series, parallel, or combined circuits. So I think each of these should have 8 wires in it. Lo and behold, this one only has 7.